welcome to this week's episode of Seeking Proof, Finding Grace. I'm your host, Ron Campbell, and this week, as with every week, I want to start off by reminding you of the most important truth in the entire universe. What we talked about last week may actually be right. The only infinite thing out there is God's infinite love for us. And we'll see that as a reality this week when we look at this question of, could the universe have existed past eternal? Now, last week we addressed the question of infinity. What does infinity actually mean? While infinity exists from a mathematical perspective, no question, when you start trying to look at infinity in the real world, you run into logical problems where it creates absurdities that cannot be addressed. I think the example we used last week that makes the most sense in all of this, if you have an infinite set of numbers and you get rid of 99% of them and you're left with 1%, how much do you have left? Infinity. You have an infinite set of numbers left, even though you've gotten rid of 99% of infinity. That doesn't really work. So that was why we talked about this idea last week. Infinity, when we look at things in the past, well, a past infinite is really not possible because you run into absurdities like that just completely blow it out of the water. Can you count numbers always adding one on into the future? Well, yeah, that's a potential infinite. You have a recognized, defined starting point, and you can keep adding one for forever, but you never actually reach infinity because you're anchored by that original starting point. Well, that anchor point in our discussion is the beginning of the universe. So the question is there a beginning of the universe that we have to recognize, or could the universe be past eternal? Has it existed for forever? You remember there were three options that we've been dealing with in this process. Option number one, we were created by an independent third party. Option number two, the universe just leapt into existence out of nothing. So out of nothing, everything came. And then option number three, the universe has existed past eternal. So we looked at this question last week of infinity to really set up this week's final conclusion as we determine, could the universe actually be past eternal? And what we recognize is that an actual infinite set of numbers extending into the past was not really possible because you run into those absurdities, those things that really, really throw a curveball into the question. But that's not the only reason that we would say the universe could not be past eternal. And again, we're going to jump all the way back to where we began this journey in 1915 with Albert Einstein's general theory of relativity. The idea that came out of Einstein's general theory of relativity, and there's a lot of ideas that came out of it. But remember, by 1931, scientists had conclusively proven that despite Einstein's insistence that the universe was static, that it had existed forever, that the universe was in fact expanding. And an expanding universe created an enormous problem. Part of the reason that we know this, and again, when we look at the scientific evidence that's available, as the universe expands, it becomes less dense. I think that makes good logical sense to us in any situation. If you think about a cloud of a colored liquid underwater, as that cloud expands, it becomes less dense. It starts to filter out through the rest of it, through the rest of the water. This is something similar. So as the universe expands, it's becoming less dense. But when we hit the rewind button on that, and we shrink the universe back down, what happens is we reach that point of a singularity. And we talked about a singularity, we talked about the idea, it's that point where our formulas break down. But it becomes this point, remember, if the universe is expanding and it's becoming less dense, well, when you rewind it back and everything collapses in on itself, you reach this point of infinite density, of infinite temperature and pressure and all of these things. You think about it, as you bring in something and you keep crushing it into a smaller and smaller space, it becomes increasingly dense. And again, this is going to be why we have the Big Bang and all of this going out, is because you have this little, firecracker is the wrong word, but that point of the singularity where all of our formulas break down is this infinite point of time and space curvature and pressure and all of these different things and density. All of these things reach a point where the formulas just stop. And that's our singularity, that's our beginning point. And the problem that creates in this idea of could the universe have existed past eternal is you can't rewind back for forever. Eventually, the universe collapses into the singularity, and the singularity becomes that stopping point. It's the hard stop that you cannot go past going back in time. It creates an absolute beginning point in the universe, again, based on the work with Einstein's general theory of relativity. So number one, we recognize from last week's episode that a past infinite is not possible. Number two, when we look at the evidence of Einstein's general theory of relativity and the conclusions that we've reached from it, we would also again determine that the universe could not have existed past eternal. And this is true whether we argue that the age of the universe is 14 billion years old or some other number. No matter how you argue that, no matter what your leanings are as it relates to the age of the universe, there is an absolute beginning point as we go back in time and we trace that backwards. Okay, so when we look at that, and we've chased that back using Einstein's general theory of relativity, is there any other evidence that we would look at and that we would point to that say, well, it's an interesting theory, and yeah, the universe is expanding, and if we bring it all the way back, I understand that it would collapse into this beginning point, this tiny point in space. Is there anything else that gives us evidence that this is actually what happened? I mean, how do we know the Big Bang actually occurred? How do we know that the universe hasn't been around for forever? Wouldn't that leave evidence? Well, that's a great question. And in 1965, scientists discovered the background radiation still present from the Big Bang. This was one of the last pieces of evidence that really locked in the conclusion that it's called the standard model, the Big Bang model, that there was an absolute beginning point of the universe, and the universe has been expanding ever since, and it leapt out from this beginning point. That's the standard model. You'll hear it referred to as that. The background radiation that was detected back in the mid-60s, that was one of the final pieces of confirmation that scientists were looking for when they said, well, if the Big Bang had occurred, it would leave behind some evidence. That was one of the last and greatest pieces of evidence that really helps us to understand that. Since there was a Big Bang, we would expect to see that evidence, and we do see that evidence out there today. So again, our first piece of evidence is past infinites are not possible. Our second piece of evidence is using Einstein's general theory of relativity in an expanding universe. We absolutely have to track back to that singularity. The third piece of evidence is the discovery of the background radiation that clearly shows that the universe did actually expand into existence in a moment that we call the Big Bang. The fourth piece of evidence that we're going to look at is something called the second law of thermodynamics. And I think this is one of the easiest things for all of us to recognize because it's something that impacts us nearly every day of our lives. When the universe began with a very low level of entropy. And there's a couple different ways to think about this idea of entropy. Think about entropy from the perspective of how much gas you've got in the tank. When the universe jumped into existence, it had an enormous amount of available energy to accomplish a lot of things. I think about last Saturday, we had some friends who came over for dinner. And when I started the day, my wife and I agreed on a list of things that I think was about a mile long of all of these chores that we were going to do to get the yard looking better and get the house ready. And we've had this big project going on in front of our home here lately. And to get everything kind of cleaned up and ready to go. And when we started the day, we had an enormous amount of energy in the tank. By the time we ended the day and our friends actually arrived for dinner, we were down to next to nothing. And it was not a late evening. We kind of wore ourselves out. By the end of the evening, you could say we began the day with a low entropy level. We had low entropy, which is high energy. And by the end of the day, we had really high entropy and we had low energy left. It had gone the other way and we had run out of gas. That's going to be true for the universe too. As we go forward and we look at our sun, eventually our sun's going to run out of gas. It's kind of a depressing thought, but eventually our sun will die and grow cold, as will every other star in the universe. And as stars grow cold and die, some of them will collapse into black holes, and eventually the universe itself will slowly grow cold and die as the available amount of energy for it to keep moving on runs out. And this is one of the problems that has perplexed scientists as they look at our universe when they try to look at it from the perspective of it being past eternal. Eventually, just like anything else, the universe runs out of gas, and that's going to be a problem. So the second law of thermodynamics is going to tell us what we basically know in every area of our lives. You can't just run on energy forever. Sooner or later, unless you put new energy back into the system somehow, eventually the universe runs out of gas and it dies. Not a very happy thought, but again, it does confirm for us that if the universe had existed past eternal, well, it would have run out of gas eons ago. And we wouldn't be here today looking at the camera and asking this question. I think the other thing that we run into in all of this is logic and reason tend to indicate this to us. You know, last week we talked a little bit about the idea of a past eternal not making sense. And I know the idea of a universe being past eternal theoretically gets us around this idea of where did it come from, but it doesn't really get around the idea. It gives us the ability to ignore it, I suppose. But honestly, at the end of the day, it's not very intellectually satisfying. When you look at the universe and say, well, the universe has been around for forever. How? The universe isn't something that needed to exist. And when we really get into the question of fine-tuning and things like that, and we look at the universe that we've got, what we're going to find is that the universe is amazing. And the universe that we've got defies explanation. But why is there anything at all? Why is there a universe? And when we look at that, there needs to be some sort of an answer. And I think logically we kind of recognize that when we look at these issues. Now, the fifth item on the list is going to be extremely problematic from a scientific perspective. You know, the second item we talked about was Einstein's general theory of relativity. But in the early 2000s, a new scientific theory came onto the scene that really poses a problem for folks who want to say that the universe is past eternal. And that theory is called the Borde-Guth-Vilenkin theorem. The Borde-Guth-Vilenkin theorem uses Einstein's special theory of relativity, again, different from the general theory of relativity, but it uses Einstein's special theory of relativity to reach the same conclusion. The universe, an expanding universe, cannot be past eternal. We're not going to go too deep into the weeds on this one. There's a lot of good information online on the Borde-Guth-Vilenkin theorem. The problem that you're going to have if you're a believer in the universe being past eternal, and there have been numerous proposals over the decades trying to get around this idea that ultimately, again, remember, by the time you reach the mid-60s, from 1931 when Einstein admits that, well, his idea on the cosmological constant was wrong and the universe is expanding, which means it can't be past eternal from Einstein's perspective. That idea of a static universe couldn't be right. All the way up to the mid-60s where we find the background radiation that exists from the Big Bang. From that point going forward, people still haven't walked away from the idea. And there have been numerous proposals, whether it's an oscillating universe, whether it's inflation or oscillating models or inflationary models or string theory or whatever it is it may be. All of these new models have come onto the scene trying to get around the idea of a starting point in the universe and to allow the universe to jump itself into existence. The Borde-Guth-Vilenkin theorem is going to apply to any expanding model of the universe, which between Einstein's general theory of relativity and the Borde-Guth-Vilenkin theorem, which uses a special theory of relativity, between the two of those, most of these new theories that have been proposed get wiped off the map. They cannot exist past eternal. The other problem that you're going to run into, and I think we talked about this a few episodes ago, to get around these issues, some scientists are inclined to propose ideas that inject such an enormous amount of intelligent fine-tuning into the example of how could the universe suddenly expand into existence from nothing? Where could it have come from? What could it have done? How could we get an infinite number of universes and all of these things? And frequently what you find is, to get around all of these issues, we ultimately end up injecting design into the universe or into some sort of a universal generating device, or machine is the wrong word, but some sort of a universal generating entity ultimately becomes heavily driven by design, which again is going to take us back to option number one, that we were created by an independent third party. The Borde-Guth-Vilenkin theorem is going to really be the final nail in the coffin of any universal model where the universe is expanding, which, again, we know that ours is. So what does all of this tell us when we put all of these things together? Is a past eternal possible? Well, no, it's really not. From a logical perspective, again, when we walk through that, while it can exist mathematically, logically in the real world, it can't exist. Einstein's general theory of relativity tells us that. The discoveries that we see from the leftover remnants of the Big Bang tell us that we had a starting point of the universe. Logic and reason tell us that. The second law of thermodynamics tells us that the universe could not have existed past eternal. And the Borde, Guth, Vilenkin theorem tells us that any expanding universe, which ours is, could not have existed past eternal. What we're talking about here is not some theological idea. You notice the idea is being put on the table as we look at this. Logical, reasonable, scientific, based on current science, based on the most current science. The universe cannot be past eternal. It's simply not possible. So where does that take us? Next week, we're going to answer that question here on Seeking Proof, Finding Grace. As always, I hope you'll hit the like and subscribe button and join us every week as we look at these questions. You can find our podcasts here on YouTube, on iTunes, or Spotify. You can also find us at prooftograce.com or at our email address, prooftograce@yahoo.com. Thank you so much for joining us this week, and I look forward to seeing you next time on Seeking Proof, Finding Grace. Thank you so much. Bye-bye.